A particle moving along the x-axis has velocity given by this expression here. At what times is the particle at rest? Well, we know that velocity is 0 when the particle is at rest. So let's just solve this cubic. So we've got x cubed minus, and the cube didn't come out, action, advanced, solve. So x cubed minus 13x squared, add 46x, take away 48 is equal to 0. So x is 2, x is 3, x is 8. So t equals 2, 3, and 8 seconds. For what range of values of t is the particle travelling in the positive x direction, travelling in the negative x direction? Well, let's just try a few values. So if we look at 0, it's travelling in the negative direction. So it probably changes at 2. So I've done v of 0 is negative. So let's look at v of 2.5. So we've got 2.5 cubed, take away 13 multiplied by 2.5 squared, add 46 multiplied by 2.5, take away 48. So that's positive. And for some reason I've lost what I was writing on, but here we go. And then somewhere between 3 and 8 we need to do. So let's replace these 2.5s with, say, 4. Probably been easier to replace them with 5 since the 5's already there. So that's negative. So let's do v of 9 just to check after 8. So replace all the 4's with 9's. And that is positive. So positive x direction between 2 and 3. And greater than 8. And negative x direction would be between 0 and 2. And also between 3 and 8. Given that the particle is initially 1 meter to the right of the origin, find an expression for the displacement of the particle at any time. So x of t is just going to be the integral of this. So that's going to be t to the 4 over 4 minus 13t cubed over 3. Then 46t squared over 2, so that's going to be 23t squared minus 48t. Initially is when t is equal to 0. So if it's initially 1 meter to the right of the origin, this must be plus 1. We want to find the displacement of the particle when t is equal to 9. So t is equal to 9. Just need to calculate that. So we're going to have 9 to the power 4 divided by 4, take away 13 times 9 to the power 3 all over 3, add 23 multiplied by 9 squared, take away 48 times 9, add 1, gives us negative 86.75. And then the distance travelled by the particle in the first 9 seconds. Now clearly the particle goes backwards and forwards quite a bit, but we can use that modulus with the integral again. So what we can do is we can integrate the velocity, which is how we got the displacement, between 0 and 9, but integrate the modulus. Once again, always make sure you write down the expression you're evaluating. So we're doing an integral from 0 to 9. I'll just use x rather than t. And there's the modulus. And it's x cubed minus 13x squared, add 46x minus 48, and that gives us 127.416 recurring. And maybe that might have been better as a fraction, 1529 over 12. But either of those would do as the answer. And of course it's in meters.